In this video, we're going to learn how to write the limit definition of a definite integral. We have a few steps. The first step is to find the value of delta x, where delta x is the upper minus the lower limit divided by n. N is the number of rectangles. If you don't know the number of rectangles, just leave it as n. Step 2 says find c sub k, where c sub k is equal to the lower limit plus k, and k determines which rectangle you're calculating, times delta x. Step 3 says find f of c sub k. This is going to be the function evaluated as c sub k, and this is the height of the rectangle that you're calculating. And then the last step is to write as a limit as n approaches infinity. So let's practice. Problem number 1 says we're looking for the integral from -1 to 1 of x cubed dx. So our first step is to find delta x. And that is going to be the upper limit minus the lower limit divided by n. So this is just going to be 2 over n. Step 2 says find c sub k. Well, c sub k is equal to the lower limit plus k times delta x. And we can clean this up a little bit. All right, step 3 says find f of c sub k. So this is the function evaluated at c sub k. Our function is x cubed, so this is going to be -1 plus 2k over n cubed. And the last step is to write as a limit as n approaches infinity. So limit as n approaches infinity of the sum from k is equal to 1 to n of this function, and this function is just going to be -1 plus 2k over n cubed times delta x. All right, remember this is the height of our rectangle, this is the base of our rectangle. We're finding the sum of all of these areas as n approaches infinity. Okay, so let's try it again. Number 2. First step, find delta x. Upper limit minus the lower limit divided by n. So this is just 3 over n. C sub k is the lower limit plus k times delta x. 1 plus 3k over n. F of c sub k is the function evaluated at that c sub k value. So 3 times 1 plus 3k over n squared. And then write it as a limit as n approaches infinity of the sum from k equals 1 to n of 3 times 1 plus 3k over n squared times dx, delta x, so times 3 over n. And I think that's our final answer. Let's try a few more examples. First step, find delta x. Upper minus the lower limit divided by n, so this is going to be 2 over n. Next step, c sub k, which is the lower limit, plus k times delta x. F of c sub k, that's the function evaluated at this, so I'm going to substitute in 2 plus 2k over n plus 3. And then now we write it as the limit as n approaches infinity of the sum from k is 1 to n of 2 times 2 plus 2k over n plus 3 times delta x. And if you want, you can distribute and clean it up just a bit, but I'll leave it like this. In problem number 4, delta x is equal to our upper minus the lower limit over n. This can't be simplified, so we'll just leave it like that. C sub k is the lower limit plus k times delta x. F of c sub k is the function evaluated, so natural log of 1 plus k times e minus 1 over n. And the last step, the limit as n approaches infinity of the sum from 1 to n rectangles. And this is the natural log of 1 plus k times e minus 1 over n times delta x. And our last example, the upper limit is pi over 3, the lower limit is pi over 6. So delta x is pi over 3 minus pi over 6 divided by n. And so this is going to give you pi over 6n. C sub k is equal to the lower limit plus k times delta x f of c sub k is equal to sine of c sub k, so that would be pi over 6 plus pi k over 6n. And our last step, the limit as n approaches infinity from k is 1 to n of sine pi over 6 plus pi k over 6n times delta x, which is pi over 6n. And that's how you write the limit definition of a definite integral.